Pascal's principle. Pascal's principle states that if an external pressure is applied to a confined and incompressible fluid, the pressure everywhere in the fluid increases by that added amount. Pascal's barrel is an experiment attributed to French scientist Blaise Pascal, but it is unclear if he ever performed this experiment. In this experiment, a 10-meter-long tube was inserted into a barrel filled with water. When water was poured into the tube, the increase in pressure caused the barrel to burst. In 2016, a Princeton University professor performed a modern-day reenactment of Pascal's experiment, and you can watch a 7-minute video about it on YouTube. Here we have a pool, a giant floating piece of ice, and a polar bear. When the polar bear jumps onto this floating piece of ice, the water pressure in the pool increases by the same amount. Since A and B are both the same depth below the surface, the pressure at both points is equal. So you might think that the pressure underneath the polar bear would increase and this pressure over here wouldn't increase, but that's not true. Pascal's principle states that the pressure everywhere in the fluid will increase by the same amount when this external pressure is added. Pascal's principle implies that the weights of layers of fluids above you, including the atmosphere, will add to the pressure you feel. If you have a container with oil floating on top of water, here's how you can calculate the pressure at every point in here. At the very top, right here, you'd have atmospheric pressure. So that would be like on the surface. Right here between these two layers, you would have atmospheric pressure and you would have pressure due to the weight of the fluid, of the oil. So that's rho GH for oil. If you wanted to find the pressure at the bottom of the whole container, you would have atmospheric pressure, air pushing down. You would have the pressure due to the oil and you would have pressure due to the water. One important application is the hydraulic lift. Pressure applied via a piston at one surface of a fluid is transmitted through the fluid to another piston where it can do work, like a lever. The result is that a small force here applied to a small area results in a large force applied to a large area. So since the pressure being increased here is going to be the same everywhere in the fluid, that same pressure is going to be applied there. Since pressure is force over area, you can see that the force here over this small area has to be equal to this force over this large area. Note that the work done is the same at each end. So force here, the force in, is applied over a greater distance. So you have to actually push this one a lot farther, and this one will only move a little bit like that, because the work done will be the same.